So yesterday we graphed sine and cosine. Today we're going to graph tangent, cosecant, and secant. So the only one we're not going to be graphing is cotangent. But we're going to graph everything else today. So right here we have the basic characteristics of the parent function of tangent. The important thing to know here is that our asymptotes for the parent function are at negative pi over 2 and pi over 2. So our asymptotes are those dotted lines that we get really, really close to but don't touch. And then our tangent graph just kind of snakes in between those two asymptotes. We have different parts of the graph. So like we'll have a snake here, one here, and it just keeps going forever, just like our sine and cosine graph just kept on going, but this is just a piece of it. When we graph these, I'm going to ask for 4 asymptotes. And 3, we'll call them snakes. So again, these are our asymptotes for our parent function. The 2 main ones are at negative pi over 2 and pi over 2. I'm going to show you how that will change if we have transformation. So we're going to look at example 1. So here I have a transformation that's happening to the x. So this is going to affect our asymptotes. So how we can find our new asymptotes is that we set x equal to, we set whatever this is. So x over 2 is equal to pi over 2. And we set x over 2 equal to negative pi over 2. So we take our parent function ones that are always pi over 2 and negative pi over 2. And we just set whatever this is happening to x equal to it. And we solve for x. So in the first one, how would I solve for x? Multiply by 2 on both sides. So x is equal to pi. Do the same thing with the second. We multiply 2 on both sides, so x is equal to negative pi. So these are our 2 main asymptotes here. So I'm going to draw my graph. I'm going to put an asymptote at pi and another one at negative pi. Our asymptotes are consistent distances apart. So how far apart is negative pi to positive pi? 2 pi. It is 2 pi apart. So to find what our next asymptote is, I just add 2 pi to get the other one. So what's pi plus 2 pi? 3 pi. So we're adding this 2 pi, the distance between our 2 main asymptotes. So then I'm going to subtract it from the one on the left to find what our other asymptote is out on the left here. So what's negative pi minus 2 pi? Negative 3 pi. So now these are our asymptotes. I'm going to draw a dotted line through each of these. Make sure you show your asymptote. Now looking at tangent that we were given, or tangent here, is it positive or negative? It is positive. Tangent is positive. So our graph snakes in between our asymptotes and is increasing. So it's going in the positive direction. If tangent was negative, it would flip. It would go decreasing. So we just snake that same shape in between all of our asymptotes. It's important when you draw your graph, you don't touch the asymptotes and don't draw a straight line. Your tangent graph is going to be a little bit squiggly. I know I'm not Picasso, so it doesn't have to be perfect, but just make sure you're not drawing a straight line and don't touch the asymptotes. And this is our graph. So let's look at example 2. So I start with my parent asymptotes, which are pi over 2 and negative pi over 2. And And I said whatever is happening to x here equal to those. So I have 2x is equal to pi over 2, and 2x is equal to negative pi over 2.
Is it always pi over 2 and negative pi?
That's what you start with, yeah. How can I solve for x? Divide by 2. We can keep change flip here. So x is equal to what? Pi over 4. And then x is equal to negative pi over 4. So let's draw our asymptotes. So I have negative pi over 4 and pi over 4. Now to figure out what our other two asymptotes are, I want to see what the distance between our main two asymptotes are. So what's the distance between negative pi over 4 and pi over 4? So I'm going pi over 4 in this direction and pi over 4 in this direction. So in between, I have 2 pi's over 4. Which I can simplify it, but I'm just going to leave it like that because I'm going to have to add it to pi over 4 and subtract it from negative pi over 4, so I'm just going to leave it over 4 to make it easier to add. So to find my other asymptote on the right, I would do pi over 4 plus 2 pi over 4, which would be, what? 3 pi over 4. And then to find my asymptote on the left, negative pi over 4 minus 2 pi over 4. So it'd be negative 3 pi over 4. Now I'm going to draw my asymptotes, so those dotted lines. Now, is our tangent positive or negative here? Negative. We have a negative 3 times tangent. So instead of increasing, we would then be decreasing. So our snake is now going in the opposite direction. So we're just going to draw our 3 snakes there. So remember, all of our tangent graphs, we need 4 asymptotes and 3 snakes. So you can cross out cotangent. We're going to skip those. And we're going to go down to cosecant and secant. So remember that cosecant is the reciprocal of sine. So we use the sine graph to help us graph the cosecant graph. So our sine graph is this one, the gray line here. The cosecant graph has the asymptotes where our sine graph is 0. So wherever our sine graph is 0, that's where we would put an asymptote. So wherever our sine graph is 0. So it will help us to draw the sine graph first. Wherever we have our line crossing 0, put an asymptote there. And then wherever, like, I guess you could call them the humps, we would just draw like a parabola on the relative max and the relative min. So it would look like that. Secant goes with cotangent, and the same thing applies whenever secant goes with cosine. Wherever cosine crosses 0, we put an asymptote there. So our asymptotes would go through wherever cosine crosses 0. And then on the relative max and min of the graph, we would just draw our parabolas. Sine is equal to 0. So like sine of theta is equal to 0. Cosecant is the reciprocal of it. So if I had 1 over 0, what is that? Undefined. So I would need an asymptote there. So example 4, We have cosecant. Cosecant goes with which function? Sine. So we're going to pretend that this is a sine function for now. I'm going to do the same thing when I graphed sine functions yesterday. So I have A, B, C, D. I need my starting point. The period. And the increments. What's the A here? 2. So remember, it goes in order. A. What's our B? 1. What's C? Awesome. We changed the sign, so it would be negative pi over 4. And what's D? 0. How do I find my starting point? C over B. So this would be negative pi over 4 over 1, which is just negative pi over 4. How do I find my period? 2 pi over B. So that's 2 pi over 1, which is just 2 pi. And then how do I find the increment? Period over 4. So 2 pi over 4, which is pi over 2. So now I can draw my graph. Remember, we're going to need our starting point plus 4 more points. So my starting point is where? Negative pi over 4. So that's in the negative direction, so it'll be to the left. So negative pi over 4. I'm going to put my asymptotes at 2 and negative 2. I'm not my asymptotes, my amplitude, sorry. Amplitude at 2 and negative 2. And now I need my increments. How do I find the next increment? I have my starting point. How do I find the next increment? Add the increment to the starting point. So negative pi over 4 plus pi over 2. I need a common denominator, so I'm going to make this 2 pi over 4. So that would be pi over 4. So my next increment is at pi over 4. To find the next increment, what would I do? Add another pi over 2. So this would be 3 pi over 4. To find the next increment, I add another pi over 2. So this would be 5 pi over 4. And let's find the fourth increment, I add another pi over 2. So this would be 7 pi over 4. You just keep adding the increment each time to find your tick marks. Now this is a sine graph. Does sine start at 0 or start at the amplitude? Starts at 0. So I start at 0. At the next increment, I go to the amplitude. Be careful. A lot of people want to go to 2 here. We go to the next increment and then go up to the amplitude. We go to the next increment, go back to 0. Next one, we go to negative 2 and then back to 0. So this is my sine graph. But we need to graph cosecant. Where would I put the asymptotes for cosecant? The asymptotes. Where our sine graph crosses 0, I put the asymptotes. So wherever our sine graph crosses 0, that's where the asymptotes go. And then my actual cosecant graph, I draw little parabolas at the relative max and min here. So it would look like that. You don't have to erase your sine graph, but make sure it's like a dotted line or something so I know that what you're talking about for your cosecant graph are the parabola shapes. So you can erase the sine graph if you want to, but you don't have to. You can leave it as just a dotted line there. But make sure it's not a solid line, because then I don't know which graph you're talking about. Right, so next we have secant of 2x. So secant goes with which trig function? Cosine. So I'm going to graph my cosine function first. So I need to figure out what A, B, C, and D are, and my starting point, my period, and the increments. What is A? The amplitude. What's our A here? 1. I don't have a number being multiplied out front, so A is 1. What is B? 2. What's C? Am I adding anything in here? So C would be 0 and D is also 0. Now for our starting point, that is C over B. So this would be 0 over 2, which is 0. So we start at 0. So on my graph, I'm going to start at 0. It's my starting point. How do I find the period? 2 pi over b, which would be 2 pi over 2. So the period is pi. And then how do I find the increments? Period over 4. So pi over 4. So my starting point is 0. How do I find the next increment? Add pi over 4. So 0 plus pi over 4 is just pi over 4. Then I add another pi over 4. 2 pi over 4, which simplifies to pi over 2. And I add another pi over 4, so 3 pi over 4. And I add another pi over 4, so 4 pi over 4, which is pi. So you need your starting point and your 4 increments. Now for our cosine graph, I need to graph the amplitude. Amplitude is at 1 and -1. For cosine graph, do we start at 0 or start at the amplitude? Start at the amplitude. So I would start up at 1, then go down to 0, down to -1, back to 0, and then up to 1. So remember, you can only go one place at a time. So I'm going to draw my cosine graph as a dotted line. That's not very pretty, but whatever. Once I draw my cosine graph, I can go ahead and graph secant. Now my secant function needs asymptotes. So where am I going to put the asymptotes? Awesome, at pi over 4 and 3 pi over 4. So wherever your cosine graph touches 0, that's where your asymptotes go. And now where am I going to put my tiny parabolas? So the point at pi over 2, so that gets 1. So at the relative maximum, at your humps, the tallest point and the lowest point. Here it's just half of 1 because we're going to say our graph starts at 0, so I would just draw my half parabola there and a half parabola over here. Make sure every max and min gets their own little parabola. This is just one cycle of the graph, one period, so it kind of cuts the parabolas in half.